All right, I'm going to finish up section 2.3. Last time we were talking about simple compound statements. We did the conjunction, which is the and the disjunction, which is the or. So our next step is we're going to look at what's called the biconditional and the conditional. And the first one we're going to look at is the conditional. It says when two statements, P and Q, are combined using a conditional, this is written as P arrow Q. And it is read, if P, then Q. The combined statement is false only when the first statement is true and the second statement is false. And this can be seen in a truth table. So again, we start the same way, true, true, false, false, true, false, and Q. And then we just kind of go through. If P is true, then Q is true. It would make this if then true, because this says if P is true, then Q is true. The second statement, this is the only time it's false, is if P is true, and then it's false. And Q is false. So it ends up to be a false statement, because this statement says that if P is true, then Q must be true. And in this case, it is not. Okay? These last two, if P is false, it really doesn't make any difference what Q is, because the statement is, if P, then Q. So we have these two statements where P is false, so it doesn't matter what Q is. So this statement is automatically true. Okay? Kind of cleaning up some definitions here. P is always going to be referred to as the antecedent, and Q is what's called the consequent. Okay? So the left side will be P, the antecedent. The second statement is Q. Okay? So let's consider a math statement. I'm thinking of a number. If I'm thinking of 6, then I'm thinking of even. So this becomes P, and this is Q. The way I would write this is I would symbolize this as P, if P, then Q. So I'm thinking of if I'm thinking of the number 6, then I'm thinking of an even number. Okay? And we have to be careful because the order really does matter here. If I say this the other way, if I'm thinking of an even number, then I'm thinking of 6. Well, those don't say the same thing. If I'm thinking of an even number, it could be any even number, not necessarily 6. So this does not equal this. So don't get those two confused. Okay? So this statement is true because if I'm thinking of 6, then I'm thinking of an even number. Okay? Because 6 is even. If I'm thinking of some other number, it could be odd or even. Okay, so this statement we would say is a true statement. All right. A lot of times you're going to see if then written a lot of different ways. If someone says, if it rains on Saturday, then I'll stay home. Okay. One would probably expect that then that if it doesn't rain, on Saturday, they would go out, which isn't necessarily true. Okay? The only time those are true is when it's a biconditional. And that would mean that P implies Q, or if P then Q, and if Q then P. So it has to go kind of both ways. And in this case, we use a double arrow to signify the biconditional. Okay? So my truth table is if P is true, then Q is true. Okay? And I kind of check it both ways. True goes to true, true goes to true. Here, if P then Q is false, so that statement has to be false. Here, if P then Q is true, but if I come back the other way, true cannot imply false, so that's false. So for the biconditional, they have to kind of match. They have to both be true or both be false. Okay? So in logic, we always refer to if then to refer to a conditional. Okay? In a biconditional, we say if and only if. Okay? So the shape is a triangle if and only if it has three sides. Okay? So this is made up of two simple statements. The shape is a triangle the shape has three sides. And the way we would write that is P if and only if Q. So we use the double arrow if we wanted to go both ways. So theorems in math class, definitions, those are all biconditionals. Okay. All right, a little bit more on this. Here, note that this is in a conditional. The order of the statements definitely matters. Okay, P implies Q is true except when Q is false and P is true. Okay, Q implies P is true except when P is false and Q is true. Okay, with a biconditional, the order doesn't really make any difference. The order does not matter. Either both statements are true or both statements are false. So suppose we have these simple statements. Ellen does the homework in the class. Ellen's final grade will be good. Okay? So we can write these conditionals or biconditionals. So P implies Q means if Ellen does the homework in class, then her final grade will be good. Okay? The other conditional would be, if I say Q implies P, now this becomes the antecedent. So if Ellen's grade, final grade I should say, final grade is good, then she did the homework in the class. Okay. All right, and we can write that in a couple different ways. Sometimes we say, if Ellen's final grade is good, then she must have done the homework. Okay. If we look at a biconditional, okay, this would say that Ellen does the homework if and only if, oops, forgot the only, if and only if Ellen's grade will be good. Okay. And again, that sounds a little different, so sometimes we'll change the tense of this. Okay. So we might put it the other way. Ellen's grade will be good if and only if, because it's a biconditional, she does her homework. Okay, so sometimes we can change it, but it has the same meaning. Okay, Ellen grade will be good if and only if she does her homework. Okay. When we use conditionals and biconditionals in English, we tend to assume that one statement causes the other to be true, but that really isn't a part of formal logic. Okay. All right. So how do we do truth tables? Okay. So, in grammar, a conjunction is a word that's used connects phrases and clauses. Okay. So in logic, a conjunction would be P and Q. Okay. The symbol we use for that, remember, is that upside down V. A disjunction would be P or Q. And the symbol we use for that, put something underneath this, doesn't write too well. The symbol we use for that is P or Q, or a V. Okay. A conditional is if P, then Q. And remember, that is our arrow. P, if and only if Q, we get this by conditional with the double arrow, P if and only if Q. Okay, and then here's our truth table for all of these. Okay, so we always start the same way: true, true, false, false, true, false, true, false. Remember the and statement, the only time it's true is when both are true. Both statements have to be true. For the or statement, the only time it's false is when both statements are false. Okay? A conditional is only true, or is only false when the antecedent is true but the consequent is false. So this is the big one here for the conditional. For the biconditional, they have to either both be true or both be false for the statement to be true. Okay? So a conjunction is true only in one row. The and is only true in one row. A disjunction, okay, and a conditional are true in 3 rows. Okay, here, 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 where a biconditional is only true in 2 rows. Okay, so sometimes this helps us decide what we're trying to connect. Okay, so let's symbolize this. I wanted to go shopping, but the stores were closed. Okay, this is made up of 2 statements. I wanted to go shopping. The store is closed. Okay. So true, 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 false. Okay. So are they both true? I want to go shopping. Then the store is closed. Yes. I want to go shopping, but the store is not closed. So this would be false. I didn't want to go shopping, so that's false. The store is not closed. I don't want to go shopping, so that's false. Okay. So since this matches our column in our truth table, which column is it? True, false, false, false. True, false, false, false. This must be the and statement. I wanted to go shopping and the store was closed. So sometimes we match the symbols to the truth table, and that helps us figure out which symbol to connect it to. Okay. All right, so that finishes up section 2.3. Go ahead and get your homework started for that section.